So in my prior videos, I talked about a lot of the analysis that had been done, or others had done, and the limited amount that I had done in terms of the epidemiology of COVID-19. I talked about how I showed a few tables that talked about risk assessment, both personal and as well as public risk. And so I had this spreadsheet that I had used, and I linked to it in the description, and I wanted to spend a little bit of time just talking about how to use that spreadsheet in case you wanted to play around with it. So here on the first tab, you have this 2 weekly confirmed cases. This is really where you would enter the most recent confirmed cases. And so you would take these prior to present, and then you would enter the values here. So for instance, you could get these by checking out the COVID-19 dashboard that's linked there. It's for this county in particular, but you can check if you just go to Johns Hopkins University or some other source that has in a particular region new confirmed cases prior to present. You can enter them here in this column, the D column. So 1 day prior to present, you'd enter it here. 2 days prior to present, you enter it there. It's set up to be a 2-week period. So you could, for instance, here's Suffolk County in the last 14 days as of February 10th. And you could enter the case numbers here. And if you have a way to export them as in a column format, you could just copy and paste them in. Otherwise, you can just type them in manually, get the values there. Once you have those, both the rest of the cumulative cases, and you also enter the population of the region that you're at. So you can get that again from the summary sheet that looks like that's from Johns Hopkins University. It has the total population, or you can look it up from some other source to get the population estimate. And then once you've entered this column and then enter the population, the cumulative cases will populate. Scrolling over the population, new cases by portion of population, and cumulative cases by portion of population populate, fill out in the spreadsheet. And then these graphs will also populate. And you have both a linear fit as well as a exponential fit. And you can try to figure out which one fits better for the current case. And you can kind of try to eyeball it, but you can also just look at the R-squared number to see which is the better fit. In this case, it was the linear case. This was from back in December 20th, 2020. Then what you want to do is you want to take the parameter values for the regression fit that are listed in the graph. So here, this is, for the, I'm looking at the portion of population, right? So that's by portion of population. This is by actual cases. So you want it to be 600 per day, plus the 8,732. You can just use the slope for the linear case, or you can take these values and you enter them in the parameter values here. So for the linear model, you have the slope, it's the m, right? So if the form is y equals mx plus d, and then the y-intercept is here, and you can enter those values in. And for the exponential model, you can enter them those values over here, right? So you would go down to the exponential model, you have 10,891 raised to the power, e raised to the power 0.147x. So you could enter those parameters back over here. And you can enter the R-squared if you want, but then the rest of the sheet doesn't populate based on that. You now have your exponential model and your linear model updated. And so now when you go to the risk assessment, this table will update both the personal risk to a family unit, updated here, as well as the expected number of people that your family unit would infect based on your behavior patterns, the number of interactions you have per day on average. Again, the number of people you're expecting to depend on the current caseload. So this is independent of current caseload, but the current risk you know, again, not super accurate, but at least qualitatively in the right ballpark. Like, you know, I presented about how I calculated these, so, you know, take it for what you will. Certainly not the most refined model, but, you know, certainly gives you an idea of what kind of risk you'd be dealing with, or at least something that I have used and feel moderately confident with. It's at least, you know, some kind of ballpark estimate, right? So if you want, you can adjust the number of interactions that each family unit has here, and that will certainly affect the entire table. And then this will add up all the family members. So each of these would be a family, an individual, and then each of these would be the number of interactions per day that individual interacts with. You get the sum for the family, and then you can, and then the rest of the table should populate just fine. Yeah. You just have to enter your family unit information. You have to enter the, oh, that's the parameters. You have to enter the slope and y-intercept or the scale factor and the exponential growth rate here, depending if you're using the linear or exponential model. But I believe this currently is only set up to, this table is only set up to use the linear model. I don't currently have this table set to populate for the exponential model. This tab right here is the improved current case estimate. So this is just like where I set the parameters that inform the rest of the model. These tend to be fixed. You can certainly play around with these and see how the model adapts as you adjust these values. For the logistics functions tab, this is where I do the modeling for the long-term outcome for you know, projections for how cases will spread based on the replication number, the transmission rate, things like that. Yeah, so the parameters are here and the parameter values are listed. You know, the parameter headings are here in the column headers, and then we have the parameter values here. Reality 2 is the most accurate one that I've come up with. And so then you can go to the graph and see what that looks like. And this should populate based on the population in that current region that you're trying to look at. So this updates based on the parameter in one of the earlier tabs that you can select, namely when you update the population in the region that you're looking at, this will also update. That graphic will also update. And if you change around, if you play around with the replication number, that will certainly change. So you only have to play around. You know, you have to do the total population on the other tab. Back at, you know, the earlier tab that I just showed, and then the replication number. If you change that here in improved case estimate, improved current case estimate, these are the parameters. You can enter the reproduction number here, and this will populate through the rest of the model. So things like model shift and transmission rate and maximum expected number infected, like that, those will all get calculated based on the replication number and the total population. You don't have to worry about those. And then the graphic will update as well. All right. Essentially, that's an overview how to use the spreadsheet. And I hope that helped clarify how you might be able to use this and play around with it as a tool for your own edification, or, you know, getting at least some qualitative, you know, sense of, you know, what, you know, how, at least how sensitive behaviors and conditions are to or how sensitive risk is to behaviors and conditions in the region you're trying to look at. All right. Feel free to leave comments in the video if you have any comments to make, or any questions or concerns or suggestions. Thank you, and be well.